the University of Colorado Boulder. Together with my collaborators, we worked on a survey on human AI decision-making, an overview of design space, and empirical human subject studies. Prior studies have shown that AI assistants help improve human performance in various tasks, and in some of the tasks, AI assistants increase human performance from 50% to at least 70%. While many studies have shown the potential of AI assistants, complementary performance has yet to be achieved. In other words, with AI assistants, human performance has yet to exceed AI performance. There are many prior and ongoing work on AI assistance in human AI decision-making tasks. Looking into the future, there are three important questions we should ask. How should we study human AI decision-making with human subject studies? What are the current trends? And lastly, what are gaps and recommendations for the field to produce more useful scientific knowledge? We aim to present a summary of the paper for the above questions in this short talk. We looked through proceedings of conferences and journals, and eventually we end up with 124 papers. And for each paper, we looked at three different aspects: the decision task, the AI model and its assistant elements, and finally the evaluation metrics that were used in the user study. We'll first look at the first aspect, decision tasks. We grouped the decision tasks into 9 domains. And the more popular ones are law and civic, medicine and healthcare, and finance and business. Existing studies on human AI decision-making cover a wide variety of tasks and many application domains. And this variety demonstrates the potential of human AI decision-making and also leads to challenges and generalization of results in developing scientific knowledge across studies. And the second current trend is task characteristics. Most existing studies focus on high-stake domains such as justice systems, medicine and healthcare, and finance, while artificial and generic tasks are still used by some. And gaps in current practice, the first one would be choice of tasks are driven by datasets availability. Due to popularity of COMPASS and ICPSR datasets, many studies use recidivism predictions as a decision task and focused on the law and civic domain. Despite the public discourse on the potential harm of AI in other domains such as hiring, there is little research on AI assistance in human resources due to a lack of available datasets. Secondly, there's a lack of frameworks for generalizable knowledge. A key question for the research community is how to develop scientific knowledge by validating and comparing results from studies across many different domains and types of decision tasks. We believe the first step is to identify different underlying characteristics of decision tasks such as risk and required expertise in order to make meaningful comparisons across studies and reconcile differences in empirical results. And finally, misalignment with application reality. The focuses and study design choices of current studies may not align with how AI is or will be used in real-world decision support applications. And now recommendations for future work. Firstly, to develop frameworks to characterize decision tasks. To allow scientific understanding across studies, there's an urgent need for the field to have frameworks that can characterize the space of human AI decisions tasks. And as a starting point, we suggest the following dimension: risk, required expertise, and existing human intuitions, subjectivity. Second, justify choices of decision tasks. We also encourage researchers to articulate the rationale behind the choice of decision task, including its suitability to answer the research questions. Researchers should also consider whether other study design choices such as system design, subject recruitment, and evaluation methods align with the characteristics of tasks. And lastly, expand datasets availability. A bottleneck hindering the community from studying broader and more realistic decision tasks is the availability of datasets. Now, we'll look at the second aspect, AI models and AI assistance elements. We group different AI model types used in the human AI decision-making into 3 categories: deep learning models, shallow models, and Wizard of Oz. And the current slide illustrates our taxonomy of AI assistance elements. And in this slide, we further group methods or AI assistance elements explored in prior work into 4 categories, as aforementioned in the previous slide. Now, the takeaways for our second aspect. The first current trend is assistance beyond predictions. Besides the prediction itself, empirical studies have explored the effect of a wide range of elements providing information about the prediction and the model on improving decision performance. And by summarizing these elements, we hope to also inform the design space of AI decision support systems. Second, a focus on AI explanations. A large portion of prior work focused on studying the effect of explanations, both local explanations for prediction and global explanations. And thirdly, beyond the model. Beyond model-centric assistance elements, a small portion of work explores system elements that affect user agency and action spaces, including workflow and user control. For gaps in current practice, the first one would be a fragmented understanding and limited design space of AI assistance elements. Current human subject studies often focus on one or a small set of AI assistance elements, and we have a very limited understanding of the interplay between different assistance elements and thus limited knowledge of how to choose between or combine them when designing AI systems. And second, focus on decision trials only instead of the holistic experience with AI. Existing work commonly experimented with participants performing discrete decision trial tasks, seeing an instance, and making a decision with AI assistance. However, in reality, when people use a decision support AI system, many other steps and aspects can affect their experience and interaction with the AI, such as system onboarding experience, workflow context, where the decision happens, and repeated experiences with the system. And lastly, generalizability. Similar to the discussion of task characteristics, it is necessary to elucidate how model types and their associated properties affect the experiment setup and generalizability of results, which can guide future studies for appropriate choices. And now recommendations for future work. First one will be human-centered analysis to define the design space of AI assistance elements. Complementary to current practices of studying fragmented AI assistance elements, the field can benefit from having top-down frameworks that define the design space of AI assistance elements needed for better human AI decision-making. And secondly, extend the design space and studies beyond decision trials. To center the research efforts on real user needs also means that we need to look beyond the discrete decision trials used by current studies, which not only lack ecological validity, but also may fail to account for many temporal, contextual, and individual factors that can shape how people perceive and interact with AI. And then finally, task-driven studies to complement feature-driven studies. Current studies are often motivated by the understanding the effect of certain assistance elements or design features. Then a decision task is chosen in an ad hoc fashion or even arbitrarily in some cases. We believe it is useful to complement current practices with task-driven studies, which may require conducting formative studies to include user studies and behaviors for a given decision task. Now we'll look at the final aspect, evaluation metrics. In this slide, we group evaluation metrics with respect to the task, and in this slide, we group evaluation metrics with respect to the AI. Now the takeaways on the first current trend, which is diverse evaluation focuses. Depending on the research questions and assistance element studies, prior studies focus on different evaluation constructs. And secondly, a focus on efficacy when evaluating decision tasks, but efficiency and subjective satisfaction are also useful indicators. Thirdly, focuses on understanding trust, system satisfaction, and fairness with regards to AI. We note that some of these focuses could be a result of the field's focus on explanation features and fair machine learning. And lastly, there's a lack of common measurements. Within a given measurement area, there exist significant variations in the choices of evaluation construct, content, and formulation. Now, gaps in current practice. The first one will be a focus on decision efficacy. There is a focus on decision efficacy, such as performance, and less emphasis on efficiency and user satisfaction. Second, the use of subjective versus objective measurements need to be better understood and regulated because these two metrics, they do not always align and the two may be in fact measuring different constructs despite some studies making mixed claims. Thirdly, subjective survey items are often used. There's a lack of practices to validate, reuse measurements, and leverage existing psychometrics or survey skills developed in ACI. As a result, it can be difficult to replicate a study or compare different studies. And lastly, for gaps in current practice, there's a variance on the coverage of measurements. Some studies measure only test efficacy or ask about user trust, but other studies cover many aspects. Now, recommendations for future work. The first one would be to make choices of evaluation metrics by research question. It is important to articulate what constructs, whether it is subjective perception or attitude, objective behavioral outcomes with regards to AI or with regards to the decision tasks, and this should be measured for the research questions or hypotheses. Secondly, we should work towards common metrics and have a shared understanding of the meanings, strengths, and weaknesses of different evaluation methods. Such an understanding is a key to rigorous and replicable science. Thirdly, we should keep reflecting on common evaluation metrics as value-laden choices. Evaluation metrics can profoundly shape the outcome of a field, and at a collective level, we should keep questioning whether the evaluation metrics we use capture what matters for stakeholders and society, and what the potential long-term outcome could be if we prioritize one set of measures over the other. We've now come to the end of this talk, and thank you for listening. We hope you have a better understanding of an overview of design space and empirical human AI subject studies.